Okay, this video is on correlation. A lot of times correlation is done in the same chapter with regression. Our textbook chose to do this with a separate chapter. So a lot of times in different textbooks or when you're looking up information about these topics, you'll see them posted together. So it's unusual that you see them in separate chapters. So just as a little review, just remember that a regression is a method that's used to determine the equation from two quantities. A correlation means that it's a method to determine whether there is a relationship between those two quantities. Our focus is on linear models. Remember, we've talked about relations. Regressions can be exponential models, quadratic models, cubic models. So there's all kinds of regressions. So there can be all kinds of correlations between those two different quantities. But our focus, again, is on linear models. So we're looking at a linear correlation coefficient. That value is called R. It is a unitless. It doesn't have a unit. Unitless. It doesn't have a unit. It is a measure that describes the strength of the linear relationship. Between two variables. It's a measure, not a measures there. So some characteristics. If you have a positive R, that means you have a positive correlation. And what that means, that as one variable increases, the other variable increases. Okay, if you have a negative R, that means you have a negative correlation. That means that as one variable increases, the other variable decreases. A third fact will be that R will always be a value between -1 and +1. And sometimes we include that word inclusive so that you know it doesn't go over -1, it doesn't go below -1, it doesn't go over +1. So if you have a +1, that is the strongest or a perfect positive correlation. If R is -1, that is a perfect or the strongest negative correlation. And then if R is 0, that is the weakest, or that is no linear correlation. So we kind of look at the correlation on a scale, here being +1, here being -1, and in the middle is 0. So if it is no correlation here at 0, values that are closer to 0 are weaker, values that are closer to +1 are stronger, values that are closer to -1 are stronger, and those that are closer to 0 then are weaker. So we judge correlation based on values. It's not always going to be exactly -1. It's not always going to be exactly +1. It's not always going to be exactly 0. There are going to be ranges in between there, and we have to judge that correlation based on the value. And so we also look at visual aids. And that visual aid is called a scatterplot. Some people call it a scattergram or a scatter diagram. And in order to construct a scatter diagram, we're just going to plot the X and Y points. On an X and Y axis. So we have some data. We have 6 days where we collected data at an electronics company. We collected the number of defective parts, and we collected the number of workers absent. And what we're wanting to do is try to determine if there is a correlation between the number of workers absent with the number of defective parts. So for our number of days, we have the number of workers absent, and then we have the number of defective parts. So we have 3 workers absent, 5 workers, no workers absent, 1 worker absent, 2 workers absent, and 6 workers absent. 15 defective parts, 22 defective parts, 7, and then 12, and then 20, and then 30. And then when we have those 2 sets of data, we use the term bivariate helps if I can spell it correctly. And that just means you have two different data, X and Y. And so when you have bivariate data, you have the independent variable. It's usually called the controlled. Which is usually the X. The Y is usually called the dependent variable. And it is usually called the other variable. And so to make our scatter plot, we're here at 0, 1, 2, 3, 4, 5, 6, and 7. This is the number of workers absent. This is the number of defective parts. And so when there was 0 absent, we had 7. When there was 1 absent, there was 12. When there was 2 absent, there was 20. When there was 3 absent, there was 15. Helps if I can do my units correctly as well, doesn't it? So 1 was at 12, 2 was at 20, 3 was at 15, 4 was at not you, 4 was not possible, 5 was at 22, 6 was at 30, 7 was not used. Okay, 1, 2, 3, 4, 5, 6. Yeah, that covers all of the data. And so there's our scatter plot. So that shows us how to create a scatter plot.